Okay, today's May 17th, 2011. Textbook page 367, Blue Notebook page 418. Guys on lesson 7.4. So yesterday we talked about the tangent ratio. So one I put at the bottom here. Okay. Today we're covering sine and cosine. And we're going to also keep tan in the mix just so you don't forget and so you see how they relate to each other. Now, the sine ratio is sine. Remember, this symbol stands for theta. It's the angle. Okay? Sine theta equals the opposite side divided by the hypotenuse. So let's say we're dealing with angle A. I'm using the same triangle for each of these, okay? I just want you to see how they differ. Angle A, opposite, and hypotenuse, okay? Cosine theta, that's the angle, is equal to the adjacent side divided by the hypotenuse. So, same angle A, adjacent is right beside it, and hypotenuse is still there. Hypotenuse never changes, remember? And finally, our tangent theta we did yesterday was opposite over adjacent. That's our opposite side. That's our adjacent side. Does anybody have any questions about that to start? We'll go into examples on how to do sine and cosine, and maybe even we'll throw a tan question in there. Are you okay with that? Okay, let's actually deal with the question now. Actually, before we do that, I would like you guys to remember something. This is a mind trick. I can't remember what the word is, but it's a way to remember it. Yes. So, what I want you guys to remember is sine. Okay, so it starts with the letter S. Opposite starts with O. Hypotenuse starts with H. So, one way people talk about it is they call it so. Okay? It can be written like this almost, as a quick way to remember it. Cosine starts with C, adjacent A and H. That would be our ka. And tangent is T-O-A, toa. So you may have heard of something like this. It's a way to remember what each of them are equal to. They call it so, ka, toa. Okay, so example number one, they give us this triangle. We named it ABC. Now, what we're going to do is I'm going to solve for theta using each of the ratios. Okay? I'll try to squeeze them in beside each other. Anyone remember the first ratio? Ratio. Starts with an S. Sine theta equals what? Okay, I'm just going to represent those with an O and an H. Okay? Now what I'm going to do, this one will be in red for now. Here's the angle, angle B. First of all, which is the hypotenuse? 26. And which is the opposite side? 10. This is opposite of our angle. So I'm going to be replacing, we have sine, still theta. Opposite is 10. Hypotenuse, whoops. The hypotenuse is 26. Okay? Now, first of all, what we're going to do is we're going to do this one step at a time. I'm going to divide 10 by 26. So hopefully you know how to do that. 10 divided by 26 in your calculator. 0.384. Now, I want to show you a trick on your calculator. I'm going to take my previous answer. Though I didn't write it all in here, it'll be much more accurate if I just use previous answers. Some of your calculators may not have that, but if you have a decent calculator, it'll have that option. If not, write down to a certain amount of decimal places. The more numbers you write, the more accurate your answer is going to be. Okay? Now remember, I'm trying to isolate for just theta, which means I have to bring sine to the other side. Now we did this with tangent yesterday. What do you think sine will become when it's on the other side? It will become sine to the exponent of negative 1, 0.384. Okay? So what I'm going to do is I'm going to push second function, which many of you have to do, sine. And then I have, see how my A and S, that means answer, is in blue? That means if I had second function, this button, it takes my old answer. So I plugged my old answer right into the calculator. This will become much more accurate. There we go. So, according to this, theta is equal to 22.6 degrees, according to our sine ratio. You know what? I don't know if I trust my sine ratio. So, cosine theta is equal to what? Adjacent over hypotenuse. Okay? Now, I'm just going to get rid of the red in here. Now, cosine theta. I'm working with the exact same angle. So I need to figure out what my adjacent is and what my hypotenuse is. First of all, which is my hypotenuse? Yeah, always opposite the right angle, always the longest side. So I'll be replacing my H with 26 once again. That's right. That's right. So our adjacent side will be 24. It's the side touching the angle that's not the hypotenuse. So technically 26 is touching it, but that's the hypotenuse. That never changes. So we're actually dealing with 24 as our adjacent. So I replace the A with 24. Now, once again, I'm going to figure out that ratio, 24 divided by 26. Now, I'm only going to write this to 3 decimal places, but like I said, I'm going to use my old answer in the calculator. So I'm going to bring cosine to the other side, solving for the angle. When I bring cosine to the other side, what does it become? Cosine a negative 1, 0.923. Okay? So that means I push second function cosine. And remember, I'm going to use my old answer again, so I'm going to do second function answer. Enter. Hey. Exact same thing, apparently. Which makes sense, because it doesn't matter which ratio I use, it should work. And since we're pros and we already know how to do tangent, let's try it anyway. Tangent theta is equal to, anyone remember? Opposite over adjacent, okay? So here we have our SO, S-O-H, cos, C-A-H, TOA, T-O-A. Now, we're going to have to figure out our opposite. So let's get rid of the blue here. Let's do it in green. Tangent. Tangent is the opposite side, still our 10, and our adjacent side is 24. 26 is what? Hypotenuse. That never changes. Okay? I'm going to stress that enough. Never stress that. So my opposite side is 10. I replace the 10 with, sorry, I replace the O with 10. I replace the A with 24. Tangent theta, 10, divide 24. Right in our ratio, 0.4167. When I put tangent to the other side, what does it become? It's a negative 1. I'm just going to put an arrow because I can't fit that in there. Okay? And when I type that in the calculator, second function, tan, that gives us our tan to the negative 1. Second function, this button, that's going to give me an ANS. Boom. So it didn't matter which ratio we used. We still got the exact same value for theta, which makes sense. That angle shouldn't change depending on what ratio we use. That angle's measurement is 22.6 degrees no matter what ratio we use. Just so happened we had all the sides so we could use any of them. What may happen though is you may only have the measurement for 2 sides, and then you're going to have to figure out which of the ratios to use. Okay, example number 3. So word problem, essentially after you read the word problem, you set up your triangle, which is very important. You need to know how, so actually let me do it. Captain Jack ship, Port Harbor, and the western target from the right triangle. From the unknown bearing angle, oh my gosh. Oh, sorry, they don't say it in the question, never mind. So anyways, we know that this side is 5 kilometers, this side is 20 kilometers. Theta is what we're trying to solve, okay? So I'm going to quickly draw out our ratios. We have our sine, that's me, what is that? Cosine theta is adjacent over hypotenuse. And finally, tangent theta is equal to opposite over adjacent. Okay? Now I need to solve for theta. All three of these ratios can solve for theta. We're going to have to figure out which one it is. So, one way to do it, well, I'll show you both ways. First of all, we're looking for this angle here. And like I said, it's important to name our triangle, so let's call it A, B, C. We're looking for our angle A in this instance. So our angle A, I have the information for what side is this, the adjacent or the hypotenuse or the opposite. Okay, that is our opposite. And this is what? Adjacent or hypotenuse? Hypotenuse. So that means I have opposite and hypotenuse. Which of the three ratios has opposite and hypotenuse? Sine, okay? Sine, sin, whatever you want to call it. So, what that means is that is the ratio we'll be using to solve this. I don't have enough information because I don't have an adjacent measurement, so I can't use the other two ratios. I don't have enough information. So we're going to use our sine. Sine theta is equal to opposite, which is 5 kilometers, over hypotenuse, which is 20. I'll quickly show you the other ones, the reason we can't solve them. Cosine theta, no idea what adjacent is, so we'll call it A, and hypotenuse is 20. I only have one number. I can't solve. I need at least two of the three variables. And same idea, tan theta, opposite is 5, adjacent, we don't know. So you could have actually plugged it into all three and figured out, oh, I can't use the other ratios, I don't have enough information. So we do have our sine. Sine theta is equal to 5 divided by 20, which is a fourth, but which is going to be 0.25, is that right? So when I bring sine to the other side, it's to the -1. We plug it in. Second function sine, 0.25, 14. So theta is equal to 14.47. Now, when you guys are working with degrees, a lot of times it's easiest if you just round to the nearest whole number. So what would this round to? It's actually really rounds to 14.5, which means it could be 15 or 14. Either one's fine. You can calculate it approximately, that's an approximate sign, 14 or approximately 15. This is more accurate. I like if you leave it. If you're willing to leave it, work with that number, okay? Approximately 14, approximately 15. That way, the only reason I round it is because if they ask me for B, well, I now know this is 90. This is, we'll say 15. My last angle, I know that a triangle has to add up to 180, so I take 180, subtract 90, subtract 15, gives me 75. Quickly solved for the other angle. So this only works for right angle triangles. Now let's say I have a triangle like this. It's 20, and I need a line here. We'll say the height is 15. Well, if I need to find this side and this side, I split this into two triangles. Then I have two right angle triangles, and we know this is 10 and 10. I can solve for my hypotenuse. I can actually use Pythagorean for that one, but say I want to know the angles. Once this angle is split in half, I can use sine, cosine, tangent to solve for the angles. This only works for right angle triangles. You have to have a right angle triangle for these ratios to work.